Good evening, everyone. In this session, we will discuss the topic momentum, and you should be able to know the principle of conservation of linear momentum and how it can be related to Newton laws of motion and how to apply this to one dimension problem. One dimension problem is, like example, object is moving in one direction, like either towards right or left. That's one dimension, or up and down. That is also a one dimension. So first, how we define momentum. So momentum, a physical quantity which is defined as a product of mass and velocity. So mass of an object multiplied by its velocity. We have, say, 2 kilogram object, and it is moving with a velocity of 5 meter per second. So what is the momentum of this object, or linear momentum? Because momentum can be a linear, it can be angular. Linear momentum means object moving in a straight line, whereas angular momentum means object is moving in a circular path. So when an object is moving in a circular path, we call that as a angular momentum. So in this session, we'll only discuss the linear momentum. The term linear momentum means when the object is moving in a straight line. So to get the momentum, or to find the momentum, basically momentum is a product of mass and velocity. So what about the mass of the object? The mass of object is 2 and the velocity is 5. So it will be 2 multiplied by 5, that is equals to 10. The unit of the mass is kilogram. Unit of velocity is meter per second. So it will be kilogram meter per second. Because momentum is a vector quantity, so vector addition rule is applied, and it should be specified by a direction. So if we consider the direction, the compass, north is there at the top, south, east is there towards right, and west is towards left. So because it is moving towards right hand side, so we can say momentum is 10 kilogram meter per second towards right, or we can also say it is towards east. Why it is important to know the momentum of an object? Because using the momentum you can identify which object will have or exert greater force, or which object will have a greater effect or impact when it collide with other objects. So example, we have two objects. One is 10 kilogram, another one is only 1 kilogram, and both objects are hitting the wall. Which object you think will have a greater impact on the wall, greater force exerted on the wall? Is it A, 10 kilogram, or B, 1 kilogram? So from this it appears that A should be, but what if I say a 10 kilogram was moving with a speed of 1 meter per second, whereas 1 kilogram was moving at a speed of 1000 meter per second? So when we calculate the momentum now, 10 multiplied by 1, so its momentum is 10 kilogram meter per second, and 1 multiplied by 1000, so it is 1000 kilogram meter per second. So not only the mass is required to study the momentum, but you need a velocity as well, and the product of the mass and velocity decide which object will have a greater impact when it collide with other substances or other surfaces. So not only by looking at the mass you cannot tell that because it is having greater mass so it will have greater impact. No, you have to know the speed at which, the velocity at which the object is moving. So to calculate the momentum, we multiply the mass with velocity. Is it clear, the concept of the momentum? Then what is the relation between the force and the momentum? How we can relate the force and momentum with each other? So an object is there of mass m, It is moving with velocity u. And after some time, its velocity changes to v. So object of mass m moving with velocity u. After some time, its velocity changes to v. The time interval for moving from position A to position B, that time interval is example t. So we have the formula of the force that F is equals to ma. That resulting force is equals to mass multiplied by acceleration. What about the acceleration of an object? So the final acceleration is the change in velocity, the final minus initial divided by time. So in place of this acceleration, if I substitute v minus u over t, so F is equals to m v minus u over t. So when we multiply this m, so it will come out as F is equals to mv minus mu divided by t. What is mv? Mass into velocity. So mass multiplied by velocity is called a momentum, but because it's a final velocity, so this is the final momentum. And here, what is mu? Mass multiplied by velocity, so that will be equal to initial momentum. So this is mv is the final momentum, mu is the initial momentum, and because there is a subtraction, a difference is there. So what we call that? We call that as the change in momentum. So we can say that the force in this example is equal to the change in momentum divided by the time interval. And whenever something is divided or it is with reference to time, so we use the term rate. So simply we can say that the force is equals to the rate of change in momentum. So this is how the momentum and the force are related to each other. Whenever the force is acting on the object, whenever there is a resultant force act on the object momentum will change, and the change in momentum in a unit time is refers to the applied force. So the formula which we can use to calculate the momentum or change in momentum, so we have the basic formula that F is equals to mv minus mu divided by t. And if force and time are multiplied, so F into t is equals to mv minus mu. And what is mv minus mu? So mv minus mu is equals to the change in momentum. So mv minus mu is the change in momentum. So we can say the change in the momentum is known as mv minus mu, or the change in momentum can be force into time. And this change in momentum, there is another term used for this. So the change in the momentum is also known as impulse. So impulse is simply the change in the momentum. So we can say force multiplied by time is equals to impulse. Is it clear? The formula for impulse, which is refers to change in momentum. So if you want to calculate impulse when force and time are given, that is force multiplied by time. Or impulse is a change in momentum, so it can be mv minus mu, that is also impulse. So depending on the question, if we know the speed and the mass of an object, we can use the second formula. But if we know the force acting on the object, for how much time this force acts to change the momentum, so we multiply the force with time to calculate the impulse. So what is the relation between the momentum and the force? That rate of change of linear momentum is proportional to resultant force act on it. So if there is a greater resultant force, the object will have a greater change in the momentum. So we have example two objects which are having same mass. The first object is 2 kilogram, as well as the second object is also 2 kg. Initially both are moving with the same initial speed, both have the same initial speed, like 10 meter per second and 10 meter per second. What we did, we applied a resultant force. Here we apply a resultant force of 30 Newton. In B we apply a resultant force of 60 Newton. Which object will have a greater change in the momentum? Which object is having a greater change in momentum, A or B? And for the force act for the same time interval, like 30 Newton is acting for 5 seconds, 60 Newton is also acting for 5 seconds. So which object will have a greater change in the momentum? So the rate of change in momentum is directly proportional to the applied force. So the one which will experience the greater resultant force will show a greater change in momentum. So as you can see, B is experiencing greater resultant force. So it will have a greater change in momentum in a unit time as compared to that of A. So the formula which relate the change in the momentum and the resultant force. So we have this formula that resultant force is equals to rate of change in momentum or final momentum minus initial divided by time. Final momentum is mv, initial momentum is mu divided by time. If we take m common, it will be v minus u over t. If it is v minus u over t, then that is refers to ma. We can also say that is equals to acceleration. So F is equals to ma, which is the force. If the force is not constant, then we'll get an average force. That's because the force is constant. If the constant force is acting, we can use this formula directly. But if the force is not constant, then we'll use final momentum minus initial divided by time. And what we will get? We will get the force that is known as the average force. So in this example, a force acting on a body of mass 2 kilograms, so mass is given 2 kg, causes its speed to change from 2 meter per second to 6 meter per second. So it is starting with 2 meter per second and it changes to 6 meter per second. Find the average force acting given that the force acts for 2 seconds. If the initial velocity of a body is in the same direction as initial velocity. If the final velocity of an object is in the same direction as the initial. So object does not change the direction. Velocity is a vector quantity. If direction does not change, we'll take the same sign. So this is 2. The object is having a mass of 2 kg and this is 4 meter per second. The mass is 2 kg. So what is the initial momentum? 2 multiplied by 2, that's equal to 4. What is the final momentum? As the final speed is 6, so 2 multiplied by 6, that's equal to 12. What will be the change in the momentum? And we have to find average force. Average force means the force is not constant here. The force is continuously changing. That's why we use the term average force. So that's final minus initial divided by time. So final momentum is 12, where initial momentum is 4 and the time interval is 2. So the average force will be 4 Newton in the direction of the original motion. What if the opposite direction, like the final velocity is opposite direction? So if the final velocity is in opposite direction, a 6 meter per second, the 2 kilogram object initially having a speed of 2 meter per second, but final speed is not same as the direction, it is in opposite direction. So if one of the velocity, because velocity is the vector quantity, so if one of the velocity we consider as the positive, the other direction will be considered as negative. So what is the momentum here? 2 multiplied by 2, that's equal to 4. What is the momentum? 6 multiplied by minus 2, so it is minus 12. So the formula to calculate the force, average force, is the change in momentum divided by the time interval. So final momentum is minus 12. This minus, the subtraction is for the change, and the initial momentum is 4. So it will be minus 12 minus 4 divided by time interval. So it took 2 seconds to change. When we calculate the average force, it will come out as minus 8. So what it shows, average force of minus 8, it means that direction of this force is opposite to the direction of the motion. Yeah, it's up to you. If we take 2 meter per second as negative, so it is up to you depending on which direction you consider as positive. The final result, the interpretation of the final result is not affected. Like example, this was 2 meter per second, a 2 kilogram object, then it changes the direction to minus 8. Now when we calculate the momentum, 2 multiplied by 2, that is, if I consider, not minus 8, that was 6 actually. So if I consider this as negative, the other one will be positive. So it means the right hand side direction is negative and the left hand direction is the positive. So when we calculate the momentum, it is minus 4 and this will be 12. So it will be 12 final minus initial divided by the time. So it will be 12 plus 4 divided by 2. That is 16 divided by 2, which is equals to 8. So you're getting a force of 8 because you're getting a positive answer. What is the positive direction? So positive direction is towards the left. So originally, if it was moving towards right, but now because you're getting a force in a positive value, so it shows that the force is acting towards left, or we can also say that force is opposite to the direction of initial motion. Is it clear, this part? So it does not make difference. It's up to you. Any one of them you can consider as a positive, the other direction will be negative. Sometimes you have a graph between the force and the time, and they ask to calculate the impulse, the change in the momentum. So whenever you have a force and time graph, It can be a constant force. So if it's a constant force, horizontal line will be there. And if they ask calculate the impulse, so how to calculate the impulse from the graph? So area under the graph will give you the impulse. If it's a linear graph, means a straight line graph. So in this case, it's the force is constant. So how to get the impulse? It will be length, because it's making a rectangle. So it will be length multiplied by width. If the force is continuously changing at a constant rate, we have to calculate the impulse from the graph. So how we can calculate the impulse or the change in momentum from the graph? So again, we'll draw perpendicular on x-axis. And what shape it will make? It will make a triangle. So we'll use the formula. In this case, we'll use the formula that is half base multiplied by height. So here it is force into time, but here it's half base into height. So force multiplied by time, we will get the impulse. But what if it's a non-linear graph? It's a curve. So what we have to do, we have to calculate the impulse. We have to calculate the area under the graph. And how to find the area of a non-linear graph? So you have to divide the graph into small segments. So force is there and time, and say this was a graph. And they ask calculate the impulse, the change in the momentum. In that case, it's a non-linear graph. For a non-linear graph, what we do, we divide our graph into small segments. So we'll draw equally spaced horizontal vertical lines first. But this will not be accurate. This will give you the approximate answer. So we do horizontal line, vertical lines, and then we'll draw equally spaced horizontal lines. And then area of each box multiplied by the number of boxes. So what we'll do, like using a length and width, we'll get the area of one box. So this will be 1, 2, 3, 4, 5, 6. First we'll take the complete boxes, 7, 8. So 23 are full boxes, complete boxes. Then 24 is these two combined 24. Then this will be 25. This will be 26. If it is more than half, you can consider that like or combination. So 27. So number of boxes are 27. And because it's a rectangle, so length into width, we'll get the area of one box multiplied by number of the boxes. That will give us the impulse, which is force multiplied by time. Is it clear how we can work out the impulse for a non-linear graph? Then what is the principle of conservation of linear momentum? This conservation of a linear momentum is state that total linear momentum of a system is constant, or in the absence of external force, the total momentum before collision is equals to total momentum after collision. So momentum is always conserved in an isolated system, the system which is not influenced by the frictional force, the air resistance, so the total momentum is always conserved. Example, we have two objects. moving in the same direction with different momentums. So before they collide with each other, example, the momentum of this object is 12 kilogram meter per second, and object A is 12 kilogram, object B is example 8 kilogram meter per second. So this is before they collide. After collision, they will change their momentum, but the total momentum won't change. The sum of the momentum will remain same. So after the collision, maybe the momentum of this object A turned to be 4 kilogram meter per second, whereas object B it turned to be 16 kilogram meter per second. So what is the total momentum? The sum of momentum before they collide, 12 plus 8, so that was 20. And what is the total momentum after collision? That is also 20. So and that is towards the right hand side, both cases. So in an isolated system, the conservation of a linear momentum state that the total momentum before collision is equals to total momentum after the collision. So if we add the vector addition also result. So if I say these are the initial velocities, initial momentums for object 1 and object 2. These are the initial momentum before collision. So in the starting momentum before collision of momentum, say this is A1 and this is B1. So when we find the resultant, first we'll draw the first vector, then we'll draw the second vector, and from tail of the first to the head of the last, that will be the resultant. So A1 plus B1 is equal to resultant. Then what happened when they collide? Their momentum changes. Example, the final momentum of A is in this direction and the final momentum of B is in this direction. So the final momentum of A is A2, final momentum of B is B2. This is the after collision. So when we add these momentums, so A2 will be there, then B2. So what happened? The resultant will be same, means that even the direction of the resultant will also be same. So the moment we add these momentums, the length of the resultant, the direction of the resultant for momentum after collision will also be same as the initial. So the vector sum of momentum before collision will be equal to the vector sum of momentums after collision. But the condition in an isolated system, a system which is not affected by external condition or external forces such as air resistance is there, friction is there, so they are not affecting the motion. Is it clear? The conservation of the momentum. So same way, the explosion, even when a bullet is fired by using a gun, they all follow the conservation of the momentum. For example, if a grenade explodes, so if the grenade explodes, what is the initial momentum of a grenade? Because it is at rest. So what is the initial momentum? The initial momentum is 0. So if initial momentum is 0, so if the initial momentum of a grenade is 0, what should be the final momentum? The final momentum should also be 0. So how the final momentum can be zero? So as this grenade explode, so it will explode into fragment parts. If one of the part is moving towards the right hand side, the other part will move towards the left hand side. So example, if I say the momentum of the particle moving towards right is 20 kilogram meter per second, momentum of particle moving towards left will be minus 20 kilogram meter per second. So what will be the resultant momentum? It will be minus 20 plus 20. So resultant momentum will be 0. So during a firework, you have observed that when a cracker explodes into fragment, it give a pattern. Why it give a pattern? Because for a firecracker, initial momentum is 0. So if initial momentum is 0, before exploding, initial is 0. So the final momentum should also be 0. That's why if one of the fragment is moving towards right, the other fragment will move towards left. If one fragment is moving up, the other fragment will move down. If one is moving at a certain angle, the other will also make certain angle. That's why this is a very common sight. Whenever there is a firework, you will observe when a firecracker explodes, it will make a certain pattern. You will never experience a firecracker explode and all the fragments are going towards one side. You will never experience this. If the fragments are visible, if all the fragments are visible, you will not experience it that all the fragments are going towards one side. Why? Because if the initial is 0, the final should also be 0. Same way, firing a rifle. So what happened? A bullet is there inside a gun or a rifle. So because the initial momentum is 0, so the final momentum will also be should also be 0. So if the bullet is moving towards the right hand side, the gun recoil and the gun will move left hand side. But you will find the bullet is moving faster, whereas gun relatively is moving slower. What is the reason for that? Because momentums are same. Momentum is a product of mass and velocity. As the mass of the bullet is small, that's why it is moving at a high speed. Whereas mass of the gun is relatively high compared to that of bullet. That's why it is recoiling at a lower speed. But the product of the mass and the velocity for the bullet is same as for the gun. That's why when the gun recoil, it always recoils because the initial momentum is 0. So the final momentum should also be 0. If the bullet is moving towards the right, the gun will recoil towards left. Is it clear? The second example related to conservation of the momentum. Then the third one, a rocket propulsion, a rocket propelled forward by exhaust gases. So using a Newton's third law, we can explain this. Example, this is a rocket. So due to a combustion, due to a burning, what happened? The exhaust gases are coming out. So according to Newton's third law, the rocket, there will be a force of the force by the rocket on the exhaust gases, and as a result, the exhaust gases will also exert force on the rocket, and this will be a conservation of momentum as well, because if the initial momentum of the rocket is 0, the final momentum should be 0. That's why if the rocket is moving, the exhaust gases are moving downward, the rocket will propel or it will move upward. So the rocket propels forward by the exhaust gases. The momentum of the rocket in the forward direction is equal to the momentum of exhaust gases in the backward direction. So example, an explosion caused a stationary object of mass 3 kg to split into two pieces. A smaller piece of mass 0.9 move off with a velocity 25. Find the velocity of the large piece. So example, if a student consider that there is an object initially, this is before and this one is after, and student by mistake consider that both of the fragment, practically it does not happen that both fragment will move in the same direction because it is against the conservation of the momentum. As initial is 0, the final should also be 0. So if one of the particle having a momentum towards right, the other should have towards left hand side. But what if a student consider both are moving in the same direction? So if initial momentum is 0, the final momentum should also be 0. So it will be 2.1 into V plus 25 into 0.9. And when we solve for V, what we will get? We'll get a negative answer here. So if we are getting a negative answer, what it shows? It shows that it is moving in opposite direction to the smaller piece. Is it clear? This question? When you solve this, you will get minus 10.7. So negative sign shows that what direction we consider that was not the correct direction. Actual direction is opposite to what we consider. Because to solve some questions, we have to consider a direction. So if we consider a direction, example right or left, if we consider right hand side, our final answer is negative. So it means the direction which we consider is not correct. It should be opposite. Is it clear this example? Explosion caused a stationary object to split into the pieces. Same way, a body of mass 1 kilogram is moving with a speed of 2 meter per second, collide with head on a mass of 2 kilogram moving with a speed of 3 meter per second. Two bodies stick together and move off. So we have to consider either they're moving towards right or left. So what is the initial momentum? It is 1 multiplied by 2. But because both are moving in opposite direction, if one of the velocity is positive, the other one will be negative. So momentum here is 2, whereas momentum here is minus 6. So that's why it's 2. Addition is there. When we get the total momentum, we add. But the result of 2 plus and minus 6, that's equal to minus 4. This should be minus 4, not minus 5, because it's 2. Then the final momentum, the mass is 3, they stick together, so total mass is 3 and the speed is v. And we consider they're moving towards the right hand side, so that's why we're taking as positive. So total momentum before collision is equals to total momentum after. So 6 divided by 3, we are getting a negative 2. So if we are getting a negative answer, what does it mean? It means that the object does not move in the direction which we consider. Actually, in practical, it moves in opposite direction. Is it clear? The concept of the momentum, the linear momentum? Any doubts? So I'll share another link and continue this discussion. We'll do exam style questions from topic momentum.